Hello there. In this particular video, I'll be going through the quotient rule. The quotient rule is a differentiation technique that is useful when two functions are divided by each other. So a key characteristic that you would like to find in this question or in the questions is when there is one function over the other. As you can see in our little examples over here, there is one function at the top and there is one function at the bottom. This is the rule from the VCAR formula sheet. Similarly to the product rule, you would see a function that is u and a function that is v. It goes as follows. You must start with v first. V times du dx. The reason why we need to start with v is because we are subtracting u times dv dx. Now, it is important that we follow the structure and we follow the rule closely as what's being given to us so as to not make a mistake. And we then divide it by v squared. Okay, so it's important to manage each of our components as carefully as possible. Alternatively, you can see that's the way we would express it with two different functions, and the interpretation is here as well, which I have just explained. Okay, so bottom function, so that's the bottom function, which is v, times the derivative of the top function, which is u, the derivative of u, minus the top function times the derivative of the bottom function over the bottom function squared. So let's put this into practice here. Again, we have to label these items here. So you can see that u is x squared. So I might go about doing that over here. I might write it up here actually. U equals x squared, which is the top function. And this means that we will have du dx. I might write that underneath actually. So that means that du dx is equal to 2x. And then we have v, which is the bottom function. So that's 2x plus 1. Hence dv dx is equal to 2. So we'll go out to write the rule first, dy dx. So here we can see that there are two functions being divided by each other, u divided by v. So the derivative of this particular function here will be v times du dx minus u times dv dx. Oops. All over v squared. So there's going to be a fair few moving pieces around, but let's go about and follow the rule. So this is an exercise of it's an exercise of being able to read a formula and being able to substitute in the correct elements into the formula. So we've got v and du dx here. Let's go and write them in. We've got 2x plus 1 times 2x minus, so we're up to this particular minus sign here in the numerator, u times dv dx, so we've got x squared times 2, all over v squared, so here's our v, and we just need to square it, which is 2x plus 1 all squared. I'm going to go to our next line again. Let's go ahead and expand the numerator, and we simplify the numerator. For intents and purposes, we'll leave the denominator in that factorized form, just so that once you get into year 12, you get into the habit of just expanding the top and simplifying the top, because that's the most common part about it. So we've got 2x times the 2x, and we're going to expand this like so. So 2x times 2x is 4x squared, plus 2x, and then we got the minus 2x squared there, all over 2x plus 1 all squared. Okay, I might jump up a line here just so we can simplify it from here. So dy dx is equal to, we'll have a look at the numerator there. We can definitely see that we have the 4x squared minus the 2x squared there, which gives us 2x squared plus 2x. Okay, and we'll leave our denominator there factorized. I think we can also factorize out the numerator. So let's take out a highest common factor of 2x there. We're left over with x plus 1 in the numerator. Now you can see here that the numerator and the denominator, unfortunately, they cannot cancel out. There are no common brackets for us to cancel out. So we're happy with that. We can leave that there. So that's one example. Let's have a look at the second example here. Again, just off to the side, I'll write it up in this space here. You can identify that, how do we know we need to use the quotient rule? Not just because it says at the top here. I think it's also important for us to identify that we have one function divided by another function. So we are finding the derivative of a particular quotient, which is a fraction or division, a division symbol involved. The u here is our top function, which is 2x plus 7, which means that du dx is equal to 2. And the v is our denominator, which is x squared plus 5x plus 2. And we want to find our dv dx, which is 2x plus 5. So let's focus a bit more on this question here. If you have a look at the formula sheet again, or if you look at the formula above this page, make sure you write it down just so that you familiarize yourself with a bit more. So we've got v times du dx minus u times dv dx all over v squared. And the more times you write this down, the more times you'll commit to memory, but also when you write it down, you give yourself a chance to familiarize yourself with the elements. So we've got v times du dx. Now I'm not just circling these because these will always be in these positions. Make sure you look at what you're substituting in, v times du dx. So we're looking at those particular elements there. We've got x squared plus 5x, that's our v, times our du dx, minus our u times dv dx. So we're looking for these two here, u times dv dx. Okay, we're going to take these two brackets here. So 2x plus 7 multiplied by 2x plus 5 all over v squared. So we're looking at v squared now. Here's our v. We're just going to square the entire thing. Okay, so we've got x squared plus 5x plus 2 all squared. I think this might take a few extra lines, so I might dip into this space below here. Let's go ahead and expand. So it's a good thing here. We're going to expand this 2 here because there's only one term. And for this one here, we're going to use the distributive law, expand the first term to each of the terms, then we're going to expand the second term across there. So we're going to expand. In the numerator, we have 2x squared plus 10x plus 4. That's our first section done. Minus, now we have to be very careful with this minus here. This is a very critical step. Minus. Everything that we expand here is still going to be negated because of the minus at the front. Negate means to have a negative on it. So let's go ahead and expand. And I'll show you why we need to put an extra pair of brackets. If we have 2x, I'm just going to pop it like this first. 2x times 2x is 4x squared plus 10x plus 14x plus 35. Okay, so the negative here will actually go into each of these terms here. If we did not put a bracket there, then this assumes that the negative will only be applied to this first term, the 4x squared. But that negative should be reaching all of the other terms, because this negative doesn't just go to this first term here, it goes to the entire expression here. Okay, so we do need that bracket. In fact, I might put that bracket in pink just so it stands out a bit more. Keep an eye on the denominator there. It's x squared plus 5x plus 2 all squared. I'm just writing that down, copying that down. Do I need to write this down every time? Yes. Practice writing down the entire expression. It does take a while, but practice. Make sure you practice. If you want to do it faster, that's absolutely fine. Don't take shortcuts. Just write the whole thing down. Okay? I'm going to simplify here a bit. We've got 10x plus 14x. That gives us a total of 24x. And then we're going to negate it. So we've got negative 4x squared here, minus 24x, minus 35. All over x squared plus 5x. And you can see now, like, you've got the denominator, just leave it in its factorized form. That's a-okay. Got dy dx here. Let's group the like terms. We've got 2x squared minus 4x squared. That's negative 2x squared there. Let's look at the x terms. 10x minus 24x, that's minus 14x. And we've got 4 minus 35, which is negative 31. Looking pretty okay there now. And then we do our v squared at the bottom there. All right, and we can leave that in that particular form there. That's absolutely fine. So this is truly an exercise of identifying terms and substituting into a formula, expanding and simplifying. Yes, there are a lot of moving pieces, so you must pay attention and take care of your working out. Write everything out clearly so that you do not miss a beat or you do not make a little mistake. Okay, thanks for watching, and make sure you get in your practice. All the best to you.